So from what you're saying, there are all these viruses competing to reproduce as fast as they can at our expense. I'm amazed that we can even survive.
You know, sometimes I am too. It's kind of a good question. I think one important point is that there are a number of viruses that infect us and replicate in us but never cause disease, that we aren't even aware are infecting us.
Really? What are some examples?
So there's been some really great research out of the University of Wisconsin run by a physician named James Gurn. And what he's done is studied babies over their first years of life and periodically sampled the babies by basically swabbing their noses. And he's found that babies are infected by just one type of virus, a rhinovirus, which is a common cause of colds, that human babies are infected by something like a new rhinovirus every month during their first year of life. And most of the time, they're inapparent infections. So it's not even, the babies don't have a cold, they're not snotty, but nevertheless, they're infected with these different viruses.
There must be some fairly fancy defenses that those babies mount to prevent those things from getting worse.
Absolutely. So I think it's a combination of the fact that you know, it's not necessarily in the virus's best interest to cause a lot of disease. If a virus kills the organism that it's trying to infect, if a virus kills us, then eventually, if it kills all of its, so if say there's a perfect virus that killed every human, well, that virus would no longer be able to replicate because all of its hosts would be dead. So it's not really in the virus's best interest to cause disease in the host. It could be, but it's not necessarily. So I think it's a combination of the fact that viruses don't necessarily, it's not advantageous to viruses to cause disease necessarily, and we have good immune systems, which is why if you have a disease like AIDS, which makes your immune system weakened, you're more susceptible to viral disease, because normally our bodies do a very good job of controlling infections by viruses.
So I'd like to talk about what people call virulence in just a second, but now let's go back to having an ordinary cold. I've often wondered if viruses, I mean, fever is useful, right, to prevent infections and make them shorter. I've often wondered if viruses have ways of disrupting our system of creating fever and other kinds of inflammatory responses. Are there examples of that?
Absolutely. So many viruses, in order to be able to successfully replicate in our bodies, have to have defenses, counter defenses against our defense mechanisms. So there's numerous examples of viral counter defenses against our bodies.
So it's like an arms race where they create a way of getting in and we create a way of blocking them, they create another way of getting around it, and it gets worse and worse.
Yeah, absolutely. There's numerous really great examples and people like to use that arms race analogy where the virus and the host are sort of continually engaged in this struggle to limit infection or to get a foothold for infection. And in fact, this is something that you can see not just on a small scale, but on a large evolutionary scale. So for instance, there are people who have done really fascinating studies on the evolution of, say, primates, and seen that different viruses, you can see evidence of these long-term evolutionary arms struggles on a long evolutionary scale.
So with an arms race, things get very expensive and costly. And of course, our immune system causes a lot of diseases. Is that a good way of thinking about it, do you think? That some of the expenses of the immune system that harm us are because of this coevolution with viruses?
Yeah, it's all a balance. So it's a balance. Our body is trying to balance the ability to defend against an infection and to limit the disease that a virus is causing, while at the same time mounting a defense that's strong enough to block infection. At the same time, the virus is trying to balance the ability to replicate itself successfully and counteract these defense systems, but not necessarily kill the host, because that's not necessarily a productive approach. So it's a very fascinating, array of things operating in a fine balance.
Actually, maybe you saw it already, but Andrea Graham's group at Princeton has an article out just last week taking a signal detection analysis of the costs and benefits of increased versus decreased aggressiveness of immune systems. And I'll give you a copy if you don't have it
sure,
already.
I haven't seen that.
Very cool stuff.
That sounds great.
Very cool stuff.